Alright, so here we have the 8-inch props that were donated by Brainstorm from RC Groups. If you wanted to see what the 8-inch props would do with the Avenger motor, give me a list of what to buy. So that's the motor that I'll be testing this with, particularly the 1200 kV, but I'll also go ahead and test them with the 1500 kV. I think it should match okay as long as the voltage is not too high, so we'll see what the amps are. So one of the largest motors for quadcopters these days, so we'll see how it does in 1200 and 3S and 4S with the 8-inch props, because there's a lot of interest now in building quads with larger props. Started with the 7-inch, but now people are trying 8-inch. I guess they want to do long range and just try something different, I guess. So here's the lineup. This one is the HQ 8x5 bullnose. Hadn't heard of this one until Brainstorm mentioned it, and it was not really readily available. I think Get FPV only had a few left, but actually it's got pretty good material. I think it's not that flexible. It's pretty stiff compared to this other HQ. This one is the 8x4.5, and this one seems to be an APC clone. Here's the APC. You can see the blade profile is pretty much the same. It looks like they just copied the APC. The APC has been around for quite a while, and if I'm not mistaken, they're the ones that came up with this airfoil design. They had it for a while, and then GenFan and HQ and everybody else has been copying them. But I think HQ, they used too flexible material here. This prop flexes a lot, I think. As you can see, compared to the HQ, it's got like a different bending profile. So this one feels much flimsy. This one has more resistance, so it's a different material. I think this has more fiber reinforcement. So the other one that I'll try, so that's the HQ 8045, the APC 8045 MR. This is the AQ 8050, and this one is the HQ 8050E. This is one of those electric motor only props, thin profile, so probably more aimed towards fixed wing aircraft, but I'll throw it in. Here's this other one that's going to be kind of interesting, the Gropner SJ 8045, and this one's a 3D prop, so it's I think it's symmetric on both sides, so I'll go ahead and try it, spinning it both ways and see if we get the same thrust. Should be the same because I can't really see any difference. It's very symmetric. And these props, I've tried them before. When I first tested the BrotherHobby, I had these before, 9-inch props, APC 9045 and MR 9045. These were donated by Justin Markland. This Master Air Screw actually did pretty well, actually, compared to the APC. This one performed better, but I don't know how it's going to be in flight. It does feel a little bit more flexible than the APC, but it made more thrust. Actually, it was just a little bit more efficient. The only thing that I hear people complaining about this one is that they don't include the adapters, and it's got an odd hub hole here for the propeller shaft, so you gotta source your own adapters. Master Air Screw should include adapters for M5 shafts. Okay, so those will be the props that I'll be testing. We'll see how they do with the BrotherHobby 2507, 1200 and 1500 kV. Alright, so here we have new motors from BrotherHobby. This one is from the Avenger series, Avenger V2. So these are 2507 and these are 1200, 1500 and 1750 kV. These are actually update to the original Avenger, so there's some new updates that make this motor much better than the original. So we'll talk about those updates and how they came about. So as usual, I want to thank Brother Hobby for sending these test samples. So Brother Hobby always has been pretty good about sending motor samples just when they first come out, sometimes even before, so I can test them and get some numbers for you guys, so you can decide whether the motor will be perfect for your setup. So Brother Hobby's always been good about that, so thank you so much, really appreciate it. So alright, let's see what's in the boxes. So the usual Brother Hobby, very simple box, which is good, you know, just cardboard, you don't need anything fancy. Let's open up the 1200 kV, and I also, as usual, there's not much in the box, just the motor and a little baggie with some mounting screws for 3mm arms and a nylock, and this one looks like it's a full size nylock. Don't know if these were sent out of the production batch, because the original ones, as you remember, had a red accent paint, so these are completely black, so I don't know if that's gonna be the color for the production units. So let's have a look at the motor. Looks pretty much the same as the original Avenger, the same design on the spokes, which is pretty cool. It's a 5-spoke pattern, and naked bottom. This looks like it's 16 by 16 mount pattern, so that's pretty good. And the main update on this motor is they went to a 4 by 9 by 4 NMB bearing, so a lot stronger bearing, and they kept the retaining screw there, and that's a 1.5mm screw, and they did use a large head screw, so even though it's 1.5, at least they use a full-size head on there, so there's a lot of area there for the driver so it doesn't slip. So sometimes when they use those really small shallow heads, they'll be very difficult to remove, and you end up messing up the screw before you even take it out, so that's good. And there we see the windings pretty much out of the way on the bottom of the motor, so that's good. There, everything's tucked in, so nothing exposed. The other motors are basically the same, so the only difference is going to be the windings, the number of turns, because that's what determines the kV value for each motor. More turns, lower kV, fewer turns, and it's a higher kV. So there we have them, 1750, 1500 and 1250. So these come with pretty good length of 18 gauge wire, so pretty hefty, pretty beefy wire that'll be able to take any load you put this in. So this is about 180 millimeters of wire, plenty of length for 7-inch arms, because that's what these were updated for. So the main purpose of Brother Hobby updating these motors is that a lot of people were asking for a 7-inch motor that could run on 6S whilst keeping amps low, so that it wasn't a battery killer. So that was the main goal of the updates they did on these motors. Davis from Brother Hobby asked me to check out the power draw on these motors, because they just wanted to confirm that on 7-inch props the draw was going to be lower than 40 amps. It was their goal to have a draw less than 40 for sure at the burst numbers, so that's pretty good, and that would be in flight. They wanted to see something that in flight wasn't going to be some crazy amp draw. So that was the main goal, which I think is pretty good, because if you have a motor that's going to be drawing a lot of amps, it's just going to discharge your battery and even kill them pretty soon. You'll get really bad voltage sag out of the battery. Alright, so let's get a weight on the motor, and that's with 195 millimeters of wire. So that'll come in quite hefty. That wire's pretty heavy, it's 18 gauge. So that comes in at 42 grams with 195 millimeters of 18 gauge wire. So if we were to cut that wire to 50 millimeters, we get rid of that much wire. As you can see, it's going to be quite heavy. That's 18 gauge. That's 435 roughly millimeters of wire. That's nearly 5 grams, 4.8 grams for that much wire if you cut it to 50, which is what I usually do. I get the equivalent weight with 50 millimeters of wire so that all the motors have the same amount of wire. The best way would actually be to, of course, no wire at all, but anyway, that's what I've been doing. So 4.8, we'll tear that with a short wire. That comes into about 37.1. So not a bad weight for such a big motor. You know, it's a 2507. Pretty good weight on that motor. It's not overly heavy. And anyways, when you put 6S on a 7-inch prop with these motors, just a few grams, it's no biggie. We'll see how easy it is to take apart this motor. So hopefully that screw comes out easily. And yeah, it looks like they're using some pretty good Loctite. I can feel the resistance, but if you just do it carefully, make sure you press in, and on one motion you turn, so you don't want to jerk anything. So the driver stays in place, and then you can turn the screw out. Okay, so that's easy to remove. Yeah, there you can see they're using that white thread lock. There's a brass washer there. So let's see, hopefully that comes out. Yeah, it looks like it's gonna come out easily. Good. And it looks like that's a 4 millimeter shaft, and it's hollow all the way through. And BrotherHobby uses the usual recipe for all their top motors. It's a titanium hollow shaft, a 7075 aluminum bell and casing, and also on the base they always go with 7075 aluminum. And on this one, as you can see, they're single strand wire, and they updated the bearings to 4x9x4, which is the proven bearing that's most durable. That's what people like, so they went ahead and changed those. And these are good quality bearings, NMB, so that's good. And let's see, there's no lip on the bell ring, but looks like there's plenty of epoxy there on the magnets, and of course those are N52 magnets. They always stay in place. I haven't seen any slip magnets lately on any of the BrotherHobby motors. Alright, so let's have a closer look under the magnifying glass, and there you can see there's a anti-slip texture on top of the bell here, where the prop is gonna rest, so that's good. And there's the one-piece titanium shaft. As always, top quality from BrotherHobby. And that's the portion where on the version 1 there's some red accent on there, so I'm not sure if that's gonna be the case on the production versions. These are pre-production, so they might change the color scheme, not sure. There's the arc magnets as usual from BrotherHobby, and there's the hollow shaft again. Here's the stator. There's the nice beefy bearings, and as usual, nice job on the windings there, pretty neat. Single strand wire, high temperature wire. So let's get a measurement on that stator. Should be 7 millimeters. So there we go. it looks pretty close to 7 millimeters. That's good, and those are 0.15 laminations, so all the tech features that we've come to expect for motors on this price range. Alright, so that's the tear down of the motor. Let's let's have a look at the air gap right there, and looks like a pretty good air gap. Looks like aimed for smoothness, so it's not ultra tight. When you have a really tight air gap, sometimes the motors are a little bit noisy, and in transition they might jerk a little. So it looks pretty typical air gap for this type of motor. So alright, let's put back that screw, and don't forget that brass washer. So alright, let's see what this motor can do on the thrust stand. Alright, so here are the thrust test results for the 8-inch props on the Avenger V2 2507 1200 kV and 1500 kV. So these props were donated by Brainstorm from RC Groups. Thanks to him, he sent me a few bucks, so I was able to buy these props, and it seems like a interesting match with the 2507 lower kV motor and these large diameter props, 8-inch on 4S and possibly 3S, but mainly on 4S, I think. So looking at the results, it almost looks like this motor might be able to handle on 5S, but I can't confirm that. So if you're gonna do it, better proceed with caution. Don't know if this motor would be too small for 5S, and it might heat saturate. It might get to a point where it's just not shedding any heat, so that's not good for the motor. Really can't say. But on 4S, the 1200 kV seems to be okay. The amps looks good. The motor never really got hot at all. It was actually running quite cool. So of course, as you can see, the thrust is not all that high even on 6S and 5-inch. This motor I think made more thrust, but with 8-inch there might be an application where this could be a good match on a larger copter that's not made for acro, maybe just for cruising, long range video. So as you can see here, the HQ 8045, not the best prop. What I noticed, flexing it side by side with the APC, this one is a little bit on the flimsy side. It's kind of flexible. The plastic just kind of bends too easily, so that could be the case. This prop could be deforming under load, so it's not it doesn't keep the shape, and that's the result right there. Then this one was a little bit of a surprise, the Grobner 3D 8045. This one performed the same both directions, so that could be interesting for those people that like to do 3D. Next one was the HQ 8050E. I think these are made for fixed wing. Oh yeah, so before I forget, I just wanted to mention about the response of this motor with these larger props might not be fast. When you go throttle high, it may lag a little bit because the stator is a little bit small compared to the props. Most are used to using 5-6-inch props and recently 7-inch props. And the 25 size, 24 size motors, even the 2207s feel responsive. You know, when you go throttle high, you get the thrust right away. But with this setup here, 8-inch props, the props are heavier, larger diameter, so the rotating mass is farther out. So it may feel a little bit laggy. I'm not sure, I haven't flown this. I just wanted to mention that these might not feel quite responsive as with the other smaller props. So that's something to keep in mind, especially with this lower KV and larger props. Move on to the this APC 8045. This one from APC performed pretty well. As you can see, both on 1200 and the 1500. Amp draw is quite reasonable here on the 1200 kV motor, 25 amps. Should be very manageable for this 1200 kV motor. And this other prop that's not really readily available, I think. There were only a few left on Get FPV, and I really haven't seen them all that much being used. The 8050 bullnose from HQ. This one actually has pretty good material. It doesn't feel as flimsy as the 8045, so this one probably has more fiber reinforcing the plastic on this one. So as you can see, it did quite well. It got the most thrust, and the amps are still quite reasonable. On the 1500 4S, the motor felt okay. It really wasn't heating up that much, but if you use it, always check motor temps. From the thrust test here, it seems that it should be able to handle this 8-inch prop. Keep in mind that these are max burst amps. In the air, once you're flying and moving forward, this number of course is going to be lower by about at least 25%, and in some cases even 35 or 40% lower once the props unload. That's the difference between the static and props that are moving through the air. They don't load as much, and of course they'll use fewer amps. Seen in the mid 40s should be manageable, I think, by this motor. And these results here with the 9-inch prop, these were from the original test. When I first tested these motors, I had these 9-inch props. I didn't have 8-inch props back then, so I did have these 9-inch props. I just threw them in here so you could just compare 8-inch to the 9-inch props. On the 1200, as you can see here, 9-inch prop seems okay, I guess, on 4S. On the 1500, I only did 3S because I thought 4S would be too much for a 9-inch prop, because I was already seeing mid-30s amps here. So, but it might be able to take 4S. But it really not a good match, I think, this size motor with a 9-inch prop on 4S. But anyway, maybe some of you will try it. So, okay, that's the results for the 8-inch props with this motor. It might be an okay match. Alright, thank you for watching.